10.8 Focus of a parabola. Essential question: can I use the directrix and focus to write the equation of a parabola? Let's take a look at a parabola. In the past, in Algebra 1, you've looked at an equation first, y is equal to x squared. You may have looked at more complicated equations, y equal to negative 2x squared, and you may have even gone into the HK format, y minus k is equal to a times x minus h quantity squared. All right, we want to take a geometric view, and the geometric view is that these set of points have a rule associated with it, very much like a circle does. A circle has the same distance from a point all the way around. Well, these set of points are the same distance from a point, which is called a focus, so this point right here, and a line, which we call a directrix. So the distance from the point to the parabola, parabola to the line are the same. Point to the parabola, parabola to the line are the same. And it says right here the vertex lies halfway between the focus and the directrix. Okay, so let's use the distance formula to write this equation. So I know that this distance is equal to this distance. So I wrote PF is equal to PD. I used the distance formula here. And there were some things that I could simplify. Like I really didn't have to write the 0, so I wrote x squared. And this becomes 0, so I only had this. I squared both sides to get rid of the square root, and I ended up getting this. Now you have to remember how to expand a binomial or a perfect square. Remember, you have to use FOIL, first, outer, inner, last. So I'm going to get a y squared minus 2a plus 4. I'm going to get the same thing here. I'm going to subtract those things that are the same. I'm going to get x squared, take all these y's to the other side, and I'm going to get 8y. So y is equal to 1/8 x squared, or I can start with y first. Y is equal to 1/8 x squared. Okay, your turn. I want you to find this distance and set it equal to this distance. Stop the screencast and see what you can do. And here's the answer. Again, take the square root and simplify, and then hopefully you square both sides and then expand, subtract things that are the same, and you get this x squared. Take all the y's to the other side, negative 12y, so y is equal to negative 1/12 x squared. Okay, the next slide tells us a formula that we can use using this relationship between a focus and a directrix. Okay, so this distance between the vertex and the focus is called P. So this is called a P distance, and on the other side of the parabola will be the directrix. So if the focus ends up being here, the directrix is on the opposite side. Now when the parabola is sideways, the parabola always likes to curve into the focus, and the directrix is always on the opposite side of the parabola. And if this is the focus, it's turning into, and then here's the directrix. Okay, let's go back to those two problems that we use the distance formula and see if I can use this brand new way to write the equation of the line and not go through so much work. So the first thing I want to do is I want to examine what P is. Now this is always P, the distance from the focus to the vertex, and that's 2. So I know that P is equal to 2. Now once I do that, I can go ahead, I know the parabola is going up. So parabolas going up have this format right here. So I'm going to write y is equal to 1/4p x squared. And now that I know p is 2, and then I'm going to get y is equal to 1/8 x squared. Now remember, I got that before with my distance formula right here. So much easier if I can just use that format. Okay, now I'm going to go to the next problem. This is the other one that I did, and let's go ahead and see if we can find the equation without going through distance formula. Now the first thing I want to do is examine what P is. P is always the distance from the focus to the vertex. Since it's going down, this is going to be a -3. So I know immediately P is equal to -3. And then I write down this equation, y is equal to 1 over 4p x squared. And then y is equal to, I'm going to substitute negative 3 in here, and I'm going to get y is equal to negative 112 x squared. Now let me show you the screen again where I went through all the distances, where you went through all the distances and got negative 112. So again, looking at this pattern is so much easier than you figuring out distances. All right, so let me go ahead and do another problem. The first thing I want to do is get x by itself. So x is equal to negative 1/4 y squared. Okay, so I want to make sure I can figure out what p is. And remember, this is the format, 1 over 4p y squared. So all this portion right here represents, let me get another color here, all of this represents this part right here. So I'm going to set them equal to each other. I'm going to say negative 4 is equal to 4p. I'm going to solve for p. P is equal to negative 1. All right, so now I know that my vertex is at 0, 0, and I know my focus is, this is a sideways parabola, and I know it's at negative 1, so I'm going to have to go over negative 1 here. So this is going to be negative 1, 0, and I know the parabola wants to hug the focus. And that means I have to go the same distance on the other side for my directrix. So I think I can start answering the questions. So my focus is going to be negative 1, 0. My directrix will be x equal to 1. Remember, x equal to is a vertical line. My axis of symmetry, this is the axis of symmetry right here. The line that divides the parabola into it's the reflecting line for the parabola. And that is going to be y equal to 0 is the axis of symmetry. And this was the directrix. And I've provided the graph. All right, let's do it again. Again, I'm going to look at where my directrix is. My directrix is here, and this reveals my P. My P is going to be, since this is 1, 2, 3, I know I'm going to do 1, 2, 3, so I know my focus is going to be 3 here. So my focus is going to be 0, negative 3. This is going down 3 like that. So I know now my P is equal to negative 3, and I could go ahead and write my equation. I know this is an up or down, so I know it has this format. Y is equal to 1 over 4p x squared. Y is equal to 1 over 4, and my P is negative 3 x squared. Y is equal to negative 1/12 x squared. And that makes sense because you have to have that negative in order for the parabola to go down. So that makes sense. Okay, your turn. Go ahead and identify the focus, directrix, and axis symmetry for this parabola. Stop the screencast and do your best. And here are the answers. I went ahead and each time I went 1 over 4p equals this, and I figured out what my P was. Once I figured out my P, then I knew my directrix was the same distance on the other side. And each time I did that. Okay, stop the screencast and see if you can use this information to write the equation of the parabola. And again, I went ahead and drew it. I drew my directrix. Every one of these parabolas has 0, 0 as their vertex. So it's a matter of you trying to figure out whether it's a sideways one or up or down. Okay, now let's take the equation from where the vertex is 0, 0, and let's move it. Let's translate it. And when we do that, we get a format that looks something like this right here. I'm going to write it this way instead. Y minus k is equal to 1 over 4p times x minus h, quantity squared. And then I'm going to write this one as x minus h is equal to 1 over 4p times y minus k quantity squared. And I'm not going to have that x and the y by itself. Okay, so this is a sideways parabola. Sideways parabolas usually look like this when they're at the origin. So just add the extra thing of saying x minus h and y minus k, and now you've done a translation. Now we can read the focus. The focus is 10, 2, and we can also read our p. P looks like it's 2, 4. That's a 4. So now we know what p is, and hk. You could just take this and substitute all these values, and here's your equation. And if you want to bring the 10 to the other side, you can and solve for x. Okay, your turn. Go ahead and see what you can do. Stop the screencast. And here's my answer. What I did is I graphed the vertex and I graphed the focus, so I got an idea of what the parabola was doing. It wants to hug the focus, so it's pointing down, and I was able to count to see what my p was. It's going to be negative since it's going down. I already had my hk. Here is the format at 0, 0. Here's the format at hk. I put my hk in, I put my p in, and I'm good to go. Last one, stop the screencast, see what you can do. And here's the answer. I went ahead and wrote y is equal to 1 over negative 4x squared. And I knew that this part right here was my 4p. So 4p is equal to negative 4, and I found my p. I knew this was a parabola going down, and I knew it wanted to hug 0, negative 1. And over here was my directrix, which is y is equal to 1. And the axis of symmetry is this red thing right here.